Hello, my dear friends, my dear students. I am Sushil, your maths teacher. Today we'll be learning complex numbers. I told you earlier there is nothing to worry about complex numbers. But the name is complex, we will make it really simple, easy to understand for you. Okay? You remember quadratic equations that you learned in your 10th standard, right? What is the general form of a quadratic equation or a second degree equation? I will write it on the board, okay? And then we will gradually come to what is complex number, right? So, have you seen this ax square plus bx plus c is equal to 0? I hope all of you remember this equation. This is the general form of a quadratic equation, okay? And how do you find the roots of this equation? Obviously, this equation is of degree 2 and it has two roots, two solutions, right? How do you find the roots of this equation? It is given by x is equal to minus b plus or minus root of b square minus 4ac the whole divided by 2a. All of you remember this? This is a very important equation which you have to remember. And b square minus 4ac, I have already told you, is called the discriminant of this equation. Okay, so once you find the value of b square minus 4ac, and if you check the value of b square minus 4ac that you obtained, then based on that you can tell what will be the nature of the roots of this equation, what will be the nature of the values of x that you get using this equation. Suppose if b square minus 4ac is positive, if it is greater than 0, then we know that both the roots of this equation will be real and distinct. Okay, you remember that? And if b square minus 4ac is equal to 0, then the roots of the equation will be equal. It will have equal roots. If one root is 2, other root also will be 2. It will be equal. Okay? That is when b square minus 4ac is equal to 0. And what if b square minus 4ac is less than 0? That is the most interesting part because we are learning the chapter complex numbers. And if b square minus 4ac is less than 0, that means it is negative, then we have square root of a negative number, and that's when you get root of minus 1. For example, if b square minus 4ac you get as say minus 4, what will happen? This will become square root of minus 4, right? So square root of minus 4 means you have the square root of a negative number, and we can write this as root of 4 into minus 1, correct? Because minus 4 is 4 into minus 1, and you can split the square root into two terms. How? This will become square root of 4 into square root of minus 1. And what is square root of plus 4? It is plus or minus 2, because plus 2 the whole square will give you 4, minus 2 the whole square will also give you the value 4. So you get the result as plus or minus 2 into what is root of minus 1? We have already learned that root of minus 1 is I. So once you understand what the relevance of the value of b square minus 4ac is, you will understand what is a complex number. When b square minus 4ac is negative, that's when you get a complex number as the square root. Clear? So you have to understand this really well. Once b square minus 4ac, the discriminant of an equation, quadratic equation, is negative, then you get the value of the roots as complex numbers. Root of minus 1 will appear in the term, and root of minus 1 is nothing but I. So you get something I as the answer. That means you get a complex number, right? So I told you that I makes a number complex number. If there is no I, there is no complex number. Okay. So any complex number has a general form, and I will write it on the board. Okay. A complex number usually we denote as the letter Z. Z is equal to A plus IB. Okay, so Z is the complex number which has two parts, which is the real part, that is A, and the imaginary part, which is B. Okay, suppose if we don't have the real part, suppose if A is equal to 0, then what we get? We get z is equal to ib only, right? So this means this complex number is purely imaginary. It doesn't have a real part, okay? And what if b is equal to 0? If b is equal to 0, then we get z is equal to a only. That means this has only a real part. So this is a real number which doesn't have a imaginary part. So we can have two cases. The real part is 0, that means you get a purely imaginary number. And the imaginary part is 0, that means you get a purely real number. So basically, generally we can say that any complex number z is equal to a plus ib, which is, we say that a is the real part and b is the imaginary part. So I makes it complex. There is no I, there is no complex number, right? Now the most important thing is the powers of I, which you need to memorize. Okay, I'll write on the board. I told you I is equal to square root of minus 1, right? So square root of minus 1 is represented by the letter I. Now what we get when we square I? What is I square? I square is nothing but I into I, right? That is the root of minus 1 into root of minus 1. And what happens when we multiply root of minus 1 with root of minus 1? The root disappears and we get minus 1, right? So you have to remember that the value of I square is minus 1. Very important in solving problems, okay? And what about I cube? I cube is I square into I, right? I means I raised to 1. So I square into I means just add the powers of I, okay? Here the power of I is 2, here the power of I is 1. So I square into I means I raised to 2 plus 1, which is I cube. Now we already know the value of I square and I, right? What is I square? We just found out. I square is minus 1. And what is I? Let it be I itself, okay? So what is minus 1 into I? It is nothing but minus I. So I cube is nothing but minus I. Just remember that, just memorize that, okay? And what about I raised to 4? I raised to 4 we can write as I square into I square. We already know the value of I square. What is I square? I square is minus 1. So we can write this as minus 1 into minus 1, which is plus 1. So you need to memorize all these values. That is I is root of minus 1, I square is minus 1, I cube is minus I, and I raised to 4 is 1. Very important. Now what if I ask you to find the higher powers of I? For example, if I ask you to find the value of I raised to 7, how will you find it out? Just think. Okay, I'll help you. I raised to 7, we can write it as either I raised to 4 into I raised to 3, right? Or we can write it as I raised to 6 into I, because just add the powers, okay? 4 plus 3 gives 7, 6 plus 1 gives 7. So these are all possible methods to find the value of I raised to 7. Okay. Now just tell me what is the value of I raised to 4. I told you that I raised to 4 is 1, okay? Remember that always. I raised to 4 is 1. And what is I cube? I cube was I square into I, that is minus I. Just substitute the value of I cube, which is minus I, and we get 1 into minus I is equal to minus I. So I raised to 7 is similar to the value of I raised to 3, okay? Now what about this? I raised to 6 into I. How do you find I raised to 6? Very simple. We know that I cube is minus I, right? If I cube is minus I, what is I raised to 6? I raised to 6 is nothing but the square of I cube, correct? Because we just multiplied 3 and 2. 3 into 2 is 6. So I raised to 6 means I cube the whole square, or you can write I square the whole cube, because the multiplication 2 into 3 will always give 6, right? So it can be either I raised to 3 the whole square or I square the whole cube. Both will give the same value, I raised to 6. Now what is I cube? I cube is minus I, right? So minus I the whole square into I, correct? Now what is minus I the whole square? Minus I the whole square is nothing but the minus becomes plus, because 1 minus I is nothing but minus 1 I, right? So minus 1 the whole square is 1. So this becomes I square into I, which is nothing but I cube again, which will again give you the value minus I. So either you can find using I raised to 4 into I raised to 3 or I raised to 6 into I, both will give you the value minus I, right? Okay, so I just told you the values of I square, I cube, I raised to 4, right? I will write it here. I square, I cube, and I raised to 4. Okay, so what are the values? I, we will write I itself. Okay, let it be I itself. What is I square? It is minus 1. What is I cube? Minus I. And what is I raised to 4? It is 1. Now, if you want to find out the higher values of I after this, the next 4 powers of I, it is very simple. The same values will be repeated. Okay, that means I raised to 5 is I raised to 4 into I, right? And we know that I raised to 4 is 1. So 1 into I will give you I itself. And what is I raised to 6? I raised to 6 is I square the whole cube, which is minus 1 the whole cube, which is minus 1. And what is I raised to 7? We already found out the value of I raised to 7. What was that? It was minus I, right? Same as I cube. And what is the value of I raised to 8? It is nothing but I raised to 4 the whole square. And I raised to 4 is 1, so 1 square is again 1. So that means the values of the powers of I gets repeated after 4 powers. I square is minus 1, I cube is minus I raised to 4 is 1. Again it gets repeated the values. I raised to 5 is again I raised to 6 again is minus 1, I raised to 7 again is minus I raised to 8 again is 1. And this will again repeat. I raised to 9 is I raised to 8 into I, right? I raised to 8 is 1. So 1 into I is again I. And again I raised to 10 will be minus 1. I raised to 11 will be minus I raised to 12 will be 1. So in short, if you have the powers of I which are multiples of 4, it will always be 1. I raised to 4 is 1, I raised to 8 is 1, I raised to 12 is 1, 16, 20, 24, etc. All the multiples of 4 coming as powers of I will give you the value 1. Clear? Understood? Right, now we will get into the real numbers, the real problems, okay? Suppose if you have a complex number given by z is equal to 2 plus 3i. So I already told you that any complex number has 2 parts, the real part and the imaginary part. So here the real part is given by 2 and the imaginary part is 3, right? Now, I will introduce something called the conjugate of this complex number. Okay, so for every given complex number z is equal to a plus ib, we have a conjugate which we represent as z bar. Okay, just put a horizontal line over z and you get the conjugate of z. Now what is the conjugate? What do you mean by a conjugate? It is very simple. It is nothing but 2 minus 3i. So generally speaking, for every complex number z is equal to a plus ib. If a plus ib is the given complex number, then what is the conjugate of z? It is denoted by z bar is equal to a minus ib. Okay, just change the plus to minus or the minus to plus, you get the conjugate of z. Let's go to the next question. A very simple one, but just try it yourself, okay? This is the question that is given here. We have to express the product of these two numbers in the form a plus ib. Okay, 7i into I divided by 9. The question is we have to express the product that we get on multiplication of these two numbers in the form a plus ib. Right, now tell me, when we multiply this, we open the bracket, 7i into I divided by 9, right? That's simple. We just open the bracket and we multiply. Now tell me, what is I into I? It is I square. Okay, so 7 I into I is I square divided by 9. Now tell me what is the value of I square. I already told you what is the value of I square. You remember? It's minus 1, right? So 7 divided by 9. I'm substituting the value of I square, which is minus 1. And I get the value minus 7 by 9. But the question is to express this product in the form A plus IB. But here we have only the real part. We don't have the imaginary part. Don't worry. If you don't have the imaginary part, just put the coefficient as 0. Okay. We have to represent this as A plus IB, right? So minus 7 by 9 we can write as minus 7 by 9, which is the real part. But we don't have the imaginary part. Absolutely no worries. Just put plus 0i. Since there is no imaginary part, we just put the value of the imaginary part as 0i. 0 into I is anyway 0. So this is the A plus IB form of minus 7 by 9. Clear? So the next topic in complex numbers, we learn what is the modulus of a complex number. Okay? So we know that Z is equal to A plus IB is the complex number. And we also learned that Z bar is equal to A minus IB is the conjugate of this complex number. Now what do we mean by the modulus of this complex number? I think let's have a look at the xy plane, the rectangular coordinates, okay? Just see this rectangular system where we have the x-axis and we have the y-axis. How do we represent Z equal to A plus IB, this complex number on the rectangular plane? Okay, so this happens to be the origin. Let's say 0, 0, the origin. And we have the real part of this complex number A and the imaginary part is B. It's very simple. The coordinates A, B on the xy plane represents the complex number. Okay, so this is the point where along the x-axis we travel A distance and along the y-axis we travel B distance, right? So this point, the coordinate A, B on the z plane, or I would say the xy plane, the complex plane, represents the complex number A plus IB, okay? Now what do you mean by the modulus of this complex number? Just join the origin and this point, okay? And the length of this particular line segment, suppose if this is the point P, which represents the complex number with coordinates AB, then the length OP is the modulus of the complex number A plus IB. It is as simple as that. Okay. If you complete the triangle, this is a right triangle, correct? This is 90 degrees because this is the x-axis and this is the y-axis. This is parallel to the y-axis, so this represents a right triangle. And we know that in a right triangle, using Pythagoras theorem, the hypotenuse OP is equal to square root of the base square plus the altitude square, which is nothing but A square plus B square. So the modulus of a complex number given by Z is equal to A plus IB is nothing but square root of A square plus B square. And how do we denote the modulus? It is given by mod Z. This is the symbol for modulus. The symbol for modulus is two parallel lines within which we put Z, that is equal to square root of A square plus B square. So the modulus of Z is square root of A square plus B square. So I believe you have understood whatever has been taught till now. It was easy for you, it was simple for you. If you have any doubts, just WhatsApp me on the given number. Okay, I will definitely attend to your messages and I will definitely try to reply to that as early as possible. Now, the next topic that we are going to learn is the addition of complex numbers. How do we add two complex numbers? Suppose we have two complex numbers given by Z1 is equal to say 2 minus 3i. So tell me what is the real part? It is 2. What is the imaginary part? It is minus 3. Most students say 3. It is not 3, it is minus 3. Please use the sign minus also, okay? So Z1 is the first complex number with the real part 2 and the imaginary part minus 3. And if I give you another complex number, say Z2 is equal to say 5 minus or say 5 plus 7i. Okay. Now my question is, how do we add these two complex numbers? Very simple. Very simple. You just take the two real parts. Which is the first real part? It is 2. Which is the second real part? It is 5. So add these two numbers. Okay. I will write it in brackets. So 2 minus 3i plus 5 plus 7i. This is what we are supposed to do. We are adding these two complex numbers. We add the corresponding numbers. That is, the real numbers, you add them. The imaginary numbers, you add them, and you will get the answer. Here the real part is 2. Here the real part is 5. So add these two. So 2 plus 5, you group it. That's the first part of the answer, the complex number that you get as the answer, which is the real part. And then plus, what is the imaginary part of the first complex number? It is minus 3i, right? So we write minus 3i. And what is the second part? The second number, it is 7i. So add these two. And what do we get? 2 plus 5, very simple, 7. And how about this one? One is minus and the other is plus. So it is basically a difference, right? So you take the biggest number, which is 7, and the smallest one is 3, and you find the difference. 7 minus 3 is 4, and 7i minus 3i is 4i. Okay? So 7 is bigger, it is positive, so we get plus 4i. It is as simple as that. That is how you add two complex numbers. Just add the real parts, add the imaginary parts, and then you express it in the form a plus ib, and that's it. Okay? And now that we have completed the addition of complex numbers, we will go into the subtraction of complex numbers, which is always very simple. Again, I will go with two numbers, z1 and z2. z1, let it be, say, I will make it more complex. Okay? But it's simple. Just follow my instructions, it is very simple. z1 is, say, minus 1 minus 2i. So I have made both the real part and the imaginary part negative. And suppose we have the second number, say z2 is equal to, I would say, 3 minus I. Right? So we have the two numbers, z1, 1 minus 2i, and the second number, z2, is 3 minus I, and we are supposed to find out the difference of these two numbers. How do we subtract two complex numbers? We have to find z1 minus z2. How do we find that? Very simple. The real part of the first complex number is minus 1. Write it down. Minus the real part of the second complex number is 3. Write it down. So that is the first part, the real part of your answer. And then plus, put a plus sign. Okay? Write the imaginary part of the first complex number, which is minus 2i. Now we have to subtract, right? So we have to write minus. Minus, which is the imaginary part of the second complex number, that is minus I. Okay, don't miss that minus. Remember, minus is always to be taken, so it is minus I. We have subtracted, right? Minus 1, minus 3, subtraction of the real numbers, plus minus 2i minus of the imaginary part of the second complex number. Now let's find out what we get. Minus 1 minus 3 means both the numbers are negative. We have minus 1 and minus 3, right? So basically this is nothing but minus 1 plus minus 3. You are adding two negative numbers. So adding two negative numbers means just add the two numbers and put the minus sign. So it is basically 1 plus 3 and you put the minus sign. So minus 1 plus minus 3 is nothing but minus 4. Because both the numbers have the same sign, they are both negative. We just have to add these numbers and put the minus sign. So you get minus 4, right? And then here also, you have minus of a minus number, which is plus. Always remember, minus of minus is equal to plus, right? So minus 2i minus of minus I means this is minus 2i plus I. So here one number is negative, the other number is positive, and if one number is negative and the other number is positive, you always have to find the difference, not the addition. Okay? So this is basically 2 minus 1. I means 1i, right? I means 1i. So minus 2i plus I means this is negative, this is positive, so find the difference. 2 minus 1, which is 1, right? Now which is bigger? Here you have 2, here you have 1i. So 2 is bigger and its sign is negative. So give the negative sign and put the I value. So minus 2i plus I is nothing but minus 1i. Why? Because one is negative and the other is positive. So basically you find the difference, you subtract it. So 2 minus 1 is 1 and 2 is bigger, which has a negative sign with it. So you put the value negative. And the answer is minus 1i. So what is the final answer? You get minus 4 minus 1i. 1i is nothing but I, okay? So you get minus 4 minus I. So minus 1 minus 3 is minus 4. Minus 2i, minus of minus I is minus 2i plus I, which makes it minus I as the answer. So the final value is, the subtracted value is minus 4 minus I. Alright, so now that we have covered the addition and subtraction of complex numbers, now we will jump into the multiplication of complex numbers. Okay, again we have two numbers, z1 is equal to say 1 plus 2i, and I would write z2 is equal to 3 minus 4i, and we are asked to find out the multiplication of these two numbers, z1 into z2. Okay, how do we find z1 into z2? So we will write the two numbers here. Let's put the brackets, 1 plus 2i into 3 minus 4i. Very simple, just like ordinary multiplication of two factors. Multiply, take the first one, the first element, multiply it by the second one. So let's do the first one. Okay, so it's basically 1 into 3 plus 1 into minus 4i, which is minus 4i, and then you take the second element of the first factor, which is 2i, right? You multiply 2i by both these numbers. So 2i into 3, what do you get? 2i into 3 is 6i, and then you have 2i into minus 4i. 2 into minus 4 is minus 8, and what is I into I? I into I is I square. And what is the value of I square? It is minus 1. So we have to remember that I square is minus 1. Only then you will get the final answer. Okay? Now let's add these numbers. 3 plus, here you have minus 4i and plus 6i. This is negative and this is positive. So what you have to find? You have to find the difference of these two numbers, right? 6 is bigger and it has a positive sign. So it is basically 6 minus 4, that is 2. And since 6 is bigger and has positive value, you would write 2i. So it is basically 6i minus 4i. If you can read from right to left, it is very simple. It is 6i minus 4i, which is clearly 2i. Now what is minus 8 into minus 1? It is plus 8. Okay. Now add these two real numbers. 3 plus 8 is 11. And you have only one imaginary number left, which is 2i. So this is the answer of the multiplication of these two complex numbers. So 1 plus 2i into 3 minus 4i, you get 11 plus 2i, with the real part 11 and the imaginary part as 2. Alright, so we covered the addition of complex numbers, subtraction, multiplication, and now we go on to the division of complex numbers. Okay, let's see how we divide two complex numbers. Suppose we have, say, z is equal to 2 plus 3i. I don't know why I always write 2 plus 3i. Maybe 2 and 3 are my favorite numbers. 2 plus 3i divided by, say, 1 minus I. We have to divide these two complex numbers and we have to express this in the form a plus ib. Okay, let's see how we do this. So just let the numerator be like that. Okay, 2 plus 3i is the numerator, let it be there. So this will be 2 plus 3i into 1 by 1 minus I. Let's write like this, okay? Let the numerator be right there, 2 plus 3I, and this we write as 1 divided by 1 minus I. So this is nothing but the multiplicative inverse of 1 minus I. How do we solve this? This is 2 plus 3I into, I told you earlier when it came to the multiplicative inverse, how do we solve 1 by 1 minus I? We have to take the conjugate of 1 minus I, which is 1 plus I, multiply the numerator and the numerator by 1 plus I, which is the conjugate, right? So this becomes 1 plus I divided by 1 minus I into 1 plus I. And what do we get? Multiply these two, the numerators. 2 into 1 is 2, 2 into I is 2I, 3I into 1 is 3I, 3I into I is 3I square, and I square is minus 1. So 3I square means minus 3, okay? That divided by, now what is 1 minus I into 1 plus I? This is nothing but A minus B into A plus B, which is A square minus B square. So this becomes 1 square minus of I square, right? So A minus B into A plus B, which is A square minus B square. So this becomes A square minus B square, that is 1 square minus I square, which we get as, now add the real numbers, 2 minus 3. 2 minus 3 is minus 1. And what is 2I plus 3I? It is 5I divided by, what is I square? Again I square is minus 1. So 1 square is 1. So 1 minus of minus 1, you get 1 plus 1, which is 2. So this is the complex number. Again, we can write it as, if you divide it separately, you get minus 1 divided by 2, which is the real part, plus 5I divided by 2, which is the imaginary part. So this is how you divide two complex numbers. You let the numerator be there and you take the multiplicative inverse of the denominator. You take the conjugate of the denominator, you multiply the numerator and denominator by 1 plus I, and then you apply the identity A minus B into A plus B is A square minus B square, and finally you arrive at the answer. That's how you solve the division of complex numbers. I hope it is clear for you. Right, so now let's try to understand a few more things, like what is additive identity, additive inverse, multiplicative identity, and multiplicative inverse of complex number. Okay? Say you have a complex number Z. What is the additive identity of Z? What do you mean by the additive identity? It is that number which, when added to Z, gives you Z. Like Z plus dash is equal to Z. Just think, what do you get? Which number here, when put here, will give you Z? Z plus something is equal to Z. That number is obviously 0, right? Z plus 0 gives you Z. So the additive identity of a complex number Z is nothing but 0. 0 is the additive identity. When you add 0 to a complex number, you get the same number Z. So 0 is the additive identity of complex numbers. How about multiplicative identity? Same concept. You have Z. What number when multiplied to Z will give you Z? It's 1. Z into 1 will give you Z. Correct? Any number multiplied by 1 will give the same number. So for any complex number, the multiplicative identity is 1. So 1 is the multiplicative identity. How about the additive inverse? Z plus something gives you 0, which is nothing but the additive identity. Okay, so which number when added to the complex number Z gives the additive identity? That number is called the additive inverse, and that is nothing but minus of Z. Right? 2 minus 2 is 0. 3 minus 3 is 0. Like that, Z plus minus Z will always give you 0. Minus Z is the additive inverse of Z. Now let's go to the multiplicative inverse. Z into which number will give you the multiplicative identity, which is 1. What is that number? Can you tell me? Z into something has to give you 1. So what is that number? We know that Z divided by Z will give you 1. Or we can say Z into 1 by Z, the reciprocal of Z will give you 1. So 1 by Z, or we can say Z raised to minus 1 is the multiplicative inverse of a complex number Z. Clear? So let's come back again. What is the additive identity of a complex number Z? It is 0, because when we add 0 to the complex number Z, we get Z itself. So 0 is the additive identity. And what is the additive inverse of Z? It is minus Z, because Z when added to minus Z gives you 0, which is the additive identity. So minus Z is the additive inverse of Z. Now coming to the multiplicative identity, Z into 1 gives you Z. So that means 1 is the multiplicative identity of a complex number Z. And what is the multiplicative inverse of Z? It is 1 by Z, because Z into 1 by Z will give you the multiplicative identity 1. Hence 1 by Z is the multiplicative inverse of a complex number Z. Right, so let's do some problems on the additive inverse and the multiplicatory inverse. Okay, suppose I have a complex number Z is equal to 5 plus 7i, and I'm asked to find out the additive inverse of this number 5 plus 7i. Very simple. It is that number which when added to this number gives 0. So just change the signs of these and you will get the answer. Okay. So we know that the additive inverse of Z is nothing but minus of Z. Right? So putting minus to each of these terms, we get minus Z. That is 5 becomes minus 5 plus 7i becomes minus 7i. And we can check whether when we add Z and minus Z, whether we get 0 or not. Okay. So what is Z plus minus Z? Z plus minus Z will give you 5 plus 7i plus minus 5 minus 7i. Right? Now what is 5 plus minus 5? It is 0. And what is 7i plus minus 7i? It is again 0. So this will yield 0. That means minus Z, that is minus 5 minus 7i, is the additive inverse of 5 plus 7i. It is that simple. Okay, so done with the additive inverse. Now let's go to the multiplicative inverse. Okay, let's use this number Z is equal to say 2 plus I. And we are asked to find out the multiplicative inverse of Z is equal to 2 plus I. It is nothing but Z raised to minus 1 or 1 by Z, right? So what is 1 by Z? It is 1 by 2 plus I. So 1 by 2 plus I is the multiplicative inverse of the complex number Z is equal to 2 plus I. How do we find this answer in the form a plus ib? We see that a plus ib is in the denominator, but we have to change that and we have to express this in the form a plus ib in the numerator. How do we do that? It's very simple. Just take the conjugate of the denominator. Now tell me, what is the conjugate of this denominator 2 plus I? It is 2 minus I, right? So the conjugate of 2 plus I is 2 minus I. Now you multiply that 2 minus I in the numerator and also in the denominator. So this becomes 2 minus I divided by 2 plus I into 2 minus I. Clear? So I have just taken the conjugate of 2 plus I, which is in the denominator, and I have multiplied that in the numerator as well as the denominator. So the effect is 0. So again, the numerator is 2 minus I divided by, now look at this, the denominator. This is something which I have seen before, right? Some identity which we have learned earlier. This is of the form a plus b into a minus b, right? Now what is a plus b into a minus b? A plus b into a minus b, we know it is a square minus b square. Remember? So a plus b into a minus b is a square minus b square. And here we have a as 2 and instead of b we have I, right? So 2 plus I into 2 minus I, applying this identity, we get what is 2 square? It is 4 minus of what is I square? I square is minus 1, right? So this is 4 minus of minus 1. I just applied this identity here. So here A is 2 and B is I. So a square minus b square means 2 square plus I square, 2 square minus I square, which is 4 minus minus 1. So this becomes 2 minus I divided by what is 4 minus of minus 1. This minus of minus becomes plus. So this becomes 4 plus 1, that is 5. So this is 2 minus I by 5. Now I have to express this in the form a plus ib. Just divide separately. 2 divided by 5 and minus I divided by 5. And that will give you the final answer. So this will come as 2 divided by 5 minus I divided by 5. Now this is the real part, 2 by 5, and this is the imaginary part, which is minus 1 by 5. Alright, so we have learned many things in complex numbers. Now a very important thing that you need to learn, a very important formula, I would say, a very important thing you need to memorize. It's very important when you do the problems in complex numbers. Okay, let's see what it is. We have told you that the conjugate of a complex number z is z bar, right? So if z is equal to a plus ib, then z bar is a minus ib, right? Now let's find out what do we get when we multiply a complex number z and its conjugate z bar. Okay, so z into z bar, this is what we are trying to find out. What do we get? Let's substitute z is a plus ib and z bar, the conjugate, is a minus ib. Now have a look at this. What do you see? This is a plus ib, this is a minus ib, just like a plus b into a minus b, right? So we have the same result here. A plus b into a minus b is a square minus b square. So similarly, we can write a plus ib into a minus ib is a square minus ib the whole square, right? This is a plus ib, this is a minus ib. A plus b into a minus b is a square minus b square. So here instead of b we have ib. So a square minus ib the whole square using the identity. Now we all know that the value of I square is minus 1, right? So when we square this term ib square, we get I square into b square. This is I square into b square. Okay, we apply the square for each of the terms. Square of I is I square, square of b is b square. So this becomes I square b square, and the value of I square is minus 1, right? So this becomes minus 1 into b square. I have just substituted the value of I square, which is minus 1. Now what is minus of minus 1? It becomes plus. So you get a square plus b square. Now this is a very important result that you need to remember. Very important in when you solve the problems. So z into z bar, or a complex number multiplied by its conjugate, the value is a square plus b square. Now I've already told you what is the value of modulus of z. What is modulus of z? That was square root of a square plus b square, right? Now what is written here? It is a square plus b square. So how do you relate these two things? The root is missing here, so this is definitely the square of this thing, right? So instead of a square plus b square, we can write the square of this thing, which is nothing but modulus of z the whole square. So a very important result that we have obtained is z into z bar is equal to mod z the whole square. Always try to remember this is really important. So how is it going? Are you getting bored? Don't worry. When I was doing my engineering, it was the same case, when I was learning mathematics, when you try to learn too many things at a time, you get bored. So just take a break, relax, have a cup of tea or black tea, come back again, and then you start all over again. Absolutely no issues, okay? So let's go back to what we have learned earlier, and we'll try some one more problem, okay? Suppose you have a complex number, say z is equal to 3 minus 5i, and you are asked to find out the value of 3 minus 5i the whole square, and you have to express this in the form a plus ib, okay? We all know the value of a plus b the whole square, right? What is a plus b the whole square? This identity, everyone knows that. A plus b the whole square is a square plus b square plus 2ab. Alright? Apply the same identity here. We have 3 minus 5 by the whole square. So instead of a, we have 3 here, and instead of b, we have minus 5i. That's all we have to substitute. So this becomes a square, that is 3 square. This is a, which is 3, plus b square, that is plus, here b is 5i, so 5i the whole square, plus 2ab, that is the product of a and b, product of 3 and minus 5i. So, yeah, actually I have to write minus 5i here because b is minus 5, okay. I have applied a plus b the whole square. You can also use a minus b the whole square, but I have used a plus b here. So, here a is 3 and b is minus 5i. So, a square is 3 square, b square is minus 5i the whole square, and 2ab means 2 into a is 3 and here b is minus 5i. So, what do I get? 3 square is 9. And what is minus 5i the whole square? Minus 5 the whole square is 25. Okay, minus square is 1. So minus 1 square is 1. So minus 5 the whole square is 25. And then we have I square. Then 2 into 3 is 6. 6 into minus 5 is minus 30. It's minus 30i. Now tell me what is the value of I square? Minus 1, right? So this is 9 plus 25 into minus 1, which is minus 25. Then minus 30i. So when I add these two real numbers, I get 9 is positive and 25 is negative. So it's basically subtraction. You subtract the smaller number from the bigger number. Here the bigger number is 25. So 25 minus 9 is 16. 25 has a negative sign. So you get the answer as minus 16. Okay. So this is minus 16 minus 30i. So that is the final answer. Okay, so we have another simple problem for you. We have gone through lots of topics in complex numbers, but a very simple problem. It's easier to solve. Just imagine, just try to memorize the powers that you have learned of I. Okay, it's a very simple problem using the powers of I. So this is I raised to 9 plus I raised to 19. So we have to find out the value of I raised to 9 plus I raised to 19. It's the powers of I. Okay, I've already told you which are the powers of I which we need to memorize. I square is minus 1. Remember that. I cube is minus I raised to 4 is 1. Okay. So using these three values, we can find any powers of I. Now, how we will find it? The value of I raised to 9. I raised to 9, I would write it as I raised to 8 into I. Why? Because I told you that any power of I, which is a multiple of 4, will give you the value 1. Because I raised to 4 is 1. So I raised to 8, I raised to 12, 16, 20, etc. will always give you the value 1. So I raised to 4 is 1, I raised to 8 is also 1. So this will give you 1 into I, which is I. So the value of I raised to 9 I got as I. Now I have to find the value of I raised to 19 similarly using these three values. Okay. How can I write I raised to 19? How can I express I raised to 19? I raised to 19 I can write as I raised to 16 into I cube. Why 16? Because it's a multiple of 4, right? So if I raised to 4 is 1, then I raised to 16 is also 1 because 16 is a multiple of 4. Okay. So this is 1 into I cube, which is nothing but I cube. What's the value of I cube? It is minus I, right? So I got the values of both these terms, I raised to 9 as I and I raised to 19 as minus I. Let's substitute the values. So I get I, this is I and this is minus I. So this becomes I plus minus I. And what is I minus I? It is 0. So the value of I raised to 9 plus I raised to 19 is 0. This is how you solve the problems in powers of I using these three values. Always remember these three values. Okay guys, so one more problem we have in the complex number section. Division we have covered it. Let's see how we do this problem. I have been asked to solve this 1 plus 2i divided by 1 minus 3i. And the question is to find out the modulus and the argument of this complex number. That means we have to express this number in the modulus amplitude form, or I would say the polar form. Okay. So first let's divide these two complex numbers and reduce it to the a plus it form. How do we do this? Already we have done this. Let the numerator be right there. Don't disturb it. 1 plus 2i, let it be there. We take the conjugate of the denominator, which is 1 plus 3i. The conjugate of 1 minus 3i is 1 plus 3i. So we multiply the numerator and the denominator by 1 plus 3i. So this is how it goes. Hope you can see this. Now we multiply the numerator. Okay. So 1 into 1 we get 1. 1 into 3i is 3i. Plus 2i into 1 is 2i. So that 3i plus 2i we get 5i. And then we do the multiplication of 2i and 3i. 2i into 3i is 6i square, and I square is minus 1. So we write as minus 6. Clear? 2i into 3i is 6i square, but I square is minus 1. So 6 into minus 1 is minus 6. Divided by, this is nothing but a minus b into a plus b, which is a square minus b square. Here a is 1 and b is 3i. So we write a square, which is 1 square, minus of 3i the whole square, that is 9i square, which we get as 1 minus 6 is how much? It is the difference of two numbers, one is positive, other is negative. So the bigger number is 6 and the sign is negative. So difference of 6 and 1 is 5. We write as minus 5 because 6 is greater, it is minus. So the answer is minus 5. Okay, plus 5i divided by 1 square is 1, and what is I square? I square is minus 1, right? So minus 9 into minus 1 is plus 9. 9 plus 1 is 10. Now we can divide this separately. So 5 divided by 10 is 1 by 2, but this is negative, so this is minus 1 by 2. Plus again 5 divided by 10 is 1 by 2. So this is the a plus ib form of this division. Okay. Now we have to express this complex number in the polar form. And we have to identify the modulus, the r, and the argument of that complex number. Okay, let's see how we do this. The polar form of this complex number is r into cos theta plus I sin theta, right? So this is the real part and this is the imaginary part. So we can write r cos theta is equal to minus 1 by 2 and r sin theta is equal to the real part, which is 1 by 2, right? Now we square these two terms, right, and we add this. Squaring this term, we get r square cos square theta is equal to 1 by 4, right? So r square cos square theta is 1 by 4 and r square sin square theta is also 1 by 4. Now we add these two terms, we can take r square in common. So what happens is r square into cos square theta plus sin square theta. We already know that cos square theta plus sin square theta is 1. So in short, we get r square is equal to 1 by 4 plus 1 by 4, which is 1 by 2. Or we get r is equal to square root of 1 by 2 which is plus 1 by root 2. We don't take the negative term because r is always positive. It is the length, it is the modulus, it's always positive. We got the r, now we need to find the theta, right? The argument. Substitute this value in these two equations and we get 1 by root 2 cos theta is equal to 1 by 2. 1 by root 2 sin theta is equal to 1 by 2. And on dividing this we get cos theta is equal to 1 by 2 divided by root 2, which is nothing but 1 by root 2. Again sin theta is equal to, just a minute, I made a mistake I think. There is a minus here. Okay, r cos theta is equal to minus 1 by 2. So I missed the minus here, sorry for that. So there is minus here. Here we have sin theta is equal to again 1 by 2 divided by 1 by root 2, which is 2 by root 2, that is 1 by root 2. Now we have got the two values of sin theta and cos theta. Now our job is to identify the value of theta which satisfies these two equations. But there is a negative sign here. Okay, we know that the angle for which both sin and cos gives 1 by root 2 is 45 degrees, which is pi by 4 radians, right? But in which quadrant is cos negative and sin positive? Let's see if this is the quadrant. Okay, we know that all sin, tan, everything is positive in the first quadrant. Sin, cos, tan, everything is positive. In the second quadrant, we know that sin is positive, rest everything is negative. In the third quadrant, tan is positive, everything else is negative. And here, cos is positive, everything else is negative. So we have to identify that quadrant, that angle for which cos is negative and sin is positive. So let's see in which quadrant that is satisfied. In the second quadrant we have sin as positive and cos is negative. So that does match our requirement. Okay. So 1 by root 2, we already know the angle is pi by 4. It is pi by 4. Right? And we identified that the angle lies in the second quadrant because cos is negative, sin is positive. Okay, so our angle is pi plus pi by 4 because this is how we measure the angle in the anti-clockwise direction. This is the direction of theta, right? So this is the first quadrant which is up to 0 to pi by 2. This is the second quadrant which is pi by 2 to pi. So yeah, it is pi by 2, sorry, it is, or we can say it is pi minus, okay, it is either pi by 2 plus pi by 4 or it is pi minus pi by 4. So we can write it as pi minus pi by 4, okay. So this angle is 3 pi by 4. When you take the LCM, 4 pi minus pi is 3 pi, so 3 pi by 4 is the angle. Now we substitute this value in the polar form and we get the polar form as, okay, I will do one, I will erase this and I will write it here. Okay, so the polar form of the given complex number is, we got r as 1 by root 2 and we got theta as 3 pi by 4. So it is 1 by root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. So this is the polar form of this particular complex number and the modulus is 1 by root 2 and the argument or the amplitude is 3 pi by 4. I hope it is clear for you. It's simple, but if you have any doubts, please do WhatsApp me, no problem, I will definitely reply to you. And now the next topic is the polar form of a complex number. We just learned that Z is equal to a plus ib, where a and b are the rectangular coordinates. Now what about the polar form of a complex number? Z is equal to ib. So we have Z is equal to a plus ib. Okay, this is the a and b are the coordinates of the complex number a plus ib. So on the complex plane we represent a, b as the coordinates. Okay, a on the x-axis and b on the, or I would say a on the real axis and b on the imaginary axis. Let's draw the axis. Okay. So we have the real axis here on the x-axis and we have the imaginary axis on the y-axis. Okay, and we know that the complex number z equal to a plus ib is represented by the point with the coordinates a and b. So this length along the real axis, the x-axis is A, and this length along the y-axis, the imaginary axis, is the imaginary part, B. So this is B. And we know that this length from the origin to this point P, OP, that length is the modulus of this complex number, which is nothing but root of A square plus B square. Now, what is the polar form of this complex number Z? You would write Z is equal to R into cos theta plus I sin theta. So this is the complex form of the complex number, the polar form of the complex number Z is equal to A plus IB. If I open the bracket, I get R into cos theta, which is the first term, plus I would write I first and then R into sin theta, we get R sin theta, right? So comparing these two terms, we get the real part A is equal to R cos theta, and the imaginary part B is equal to R sin theta. And if you see, R cos theta is the real part and R sin theta is the imaginary part. Now what do we get when we square these two terms and add it? We already said that A is equal to R cos theta, comparing these two, this form and this form. So comparing these two, we get A is equal to R cos theta and B is equal to R sin theta. What happens when we square these two terms and add it? That means A square plus B square. Now we know that A is equal to R cos theta. So what is A square? It is R square cos square theta. And what is B square? It is R square sin square theta, right? And we see that R square is common to both these terms. We can take this outside, so this becomes R square into cos square theta plus sin square theta. I hope all of you remember this formula. What is cos square theta plus sin square theta? We have learned this very early. Cos square theta plus sin square theta is always 1. Okay, so this becomes R square. So we get A square plus B square is equal to R square, or we can say R is equal to square root of A square plus B square. And this is nothing but the modulus of this complex number, right? Z equal to A plus IB, the modulus is given by root of A square plus B square. So what is R in the polar form? The R in the polar form of a complex number represents nothing but the modulus of the complex number, right? And theta, we call it the argument or the amplitude. This angle that the modulus of Z makes with the real axis. This is the angle theta. Hope you understood. So this is the polar form of the complex number Z is equal to A plus IB, given by R into cos theta plus I sin theta. If we open the bracket, we get R cos theta as the real part and R sin theta as the imaginary part. And theta, we call it the amplitude or the argument of the complex number. So this is basically the polar form diagrammatic representation. Okay. Alright, so we just studied the polar form of the complex number, and let's do a problem on the polar form of the complex number. Okay. So we are given a complex number 1 plus I root 3 or root 3i. You can say it both ways, I root 3 or root 3i. Okay. So 1 plus I root 3 is the given complex number, and we are asked to write the polar form of this complex number. So let's write down what is the polar form. Okay. We know that the complex number 1 plus I root 3, or in general A plus IB, the polar form is given by Z is equal to R into cos theta plus I sin theta. Right? Where R is the modulus of the given complex number and theta is the argument. Okay. Now we have to find R and theta, that is the A. Now how do we do that? Just compare these two, this 1 plus I root 3 and R cos theta plus I sin theta. Here, the real part of this complex number in the polar form is R cos theta, and here the real part is 1. Okay, so both have to be equal. So just write down R cos theta, which is the real part of this complex number, which is equal to 1. Okay. And what is the imaginary part of this complex number? It is r sine theta. Okay, so we compare these two and we find that r sine theta is equal to root 3. Here the coefficient of I is r sine theta. Here the coefficient of I is root 3. So both have to be equal. Okay, so we get r sine theta is equal to root 3. Clear? Any doubts? I repeat, just compare these two and equate it. Okay, r cos theta is the real part here. Here the real part is 1. So they both have to be equal. So r cos theta is equal to 1. Here the imaginary part is r sine theta. Here it is root 3. So both have to be equal. So r sine theta is equal to root 3. Clear? Now just square these two and add it. Okay, square this one. What do you get? You get r square cos square theta is equal to 1. And here you get r square sine square theta is equal to, what is the square of root 3? It is 3. Okay. Now add these two things. Okay, I'm adding these two. So what do we get? 1 plus 3, right? So I get this is equal to 4. I got r square cos square theta plus r square sine square theta is equal to 1 plus 3, which is 4. R square is common here, right? So I'm taking it outside, so we get r square into cos square theta plus sine square theta is equal to 4. And we have already said that the value of cos square theta plus sine square theta is 1. So this becomes r square is equal to 4. This becomes 1. So we get r square is equal to 4. And r is the modulus, which is never negative. So we don't have to take the negative value. R square is 4, you get r is equal to plus or minus of 2, right? Square root of 4 is plus or minus of 2. But since r is always positive, it is the modulus, we take the positive value only. So I get r is equal to 2. Okay? Substitute the value of r right here. So what do I get? I get 2 cos theta is equal to 1 and 2 sin theta is equal to root 3. Correct? So what is cos theta? It is 1 by r, which is 1 by 2. So I get cos theta is equal to 1 by 2 and sin theta is equal to root 3 divided by r, which is root 3 divided by 2. Now, you need to remember the table of the angles of sine and cos to understand what is the angle corresponding to this, which satisfies these values. Cos theta is equal to half and sin theta is equal to root 3 by 2, which is that angle theta for which these two equations are being satisfied. Cos 60 is 1 by 2, sin 60 is root 3 by 2. So that means the value of theta is 60 degree, or in radians we can say pi by 3 radians, correct? So I get theta is equal to pi by 3 radians. We always write in radians in the polar form. Okay, so I got the value of r as 2 and the value of theta as pi by 3. Now just substitute here in the polar form and you get the final answer as z is equal to r is 2. So 2 into cos, what is the angle we got? It is pi by 3. So cos pi by 3 plus I sin pi by 3. So this is my polar form, which is corresponding to the given complex number 1 plus I root 3. So the modulus is 2 and the argument is pi by 3. Hope it is clear to you.